Hello and welcome to the lecture 3 of the learning and memory course that we have been going through. In the last lecture we kind of ended with the description of Pavlov's experiment with the dogs. I said there just to recollect what we said there, and I said there that he identified in a given setting you can think of two kinds of stimulus. A stimulus that can naturally elicit a response by itself in an animal, he called it as unconditional stimulus US, and the response it elicits as unconditional response UR, and there is another kind of stimulus, conditional stimulus. These stimuli do not have a natural response in this context. It is important to note they do not have a response in this context, right. They can have a response in a different context, but in this context they do not have a response. But when you present them along with an unconditional stimulus, over a period of time they develop an association such that they by themselves can elicit a response. He called this response conditional response, the response to the conditional stimuli alone after it has been trained, it has been paired with the unconditional stimulus. He called that as conditional response. In his dog and food and metronome experiment, both the UR and the CR are happen to be same salivation. They need not be the same, and in fact in the present day experimental setting they are not the same, and you we will see what this present day experimental setting is, and there you will realize why it could not, it will not be the same, and what do I mean by saying that UR and CR can be different. Now here the important point I want to drive across is that when I described and when I put across this slide and then described this experiment, I said it is often misconceived that the way the Pavlovian conditioning works is that over repeated presentations of the conditional stimulus along with the unconditional stimulus, the dog develops an expectation for unconditional stimulus that when you play the bell it is going to bring the food, it is going, and as a result I need to prepare and that is why it has been salivating. Now that notion is not only incorrect, but it seems very intuitive, but it is highly incorrect, and it does not gel well with the real experimental evidences that we have. Now instead what I am going to try to tell you and then try to convince you is that the CS in here, the bell, the dog thinks that the bell is the food, that is the CS kind of replaces the unconditional stimulus here. Basically CS by itself develops a new response, and that is it, and that is nothing more than that. Alright. Now if the CS is developing a new response, and what determines when to develop this new response, how to develop this new response, and when not to develop this new response. These are the questions that Pavlov and many other people following him try to address. One of the earliest and the simple minded reasoning of how this association can happen is that, hey look, you are presenting the conditional stimulus and unconditional stimulus together. So maybe all the stimuli that are presented together tend to develop an association. That is to say, if you have contiguous stimuli then that are highly likely to develop they are highly likely to develop an association such that later on when you are presenting the conditional stimuli they are capable of eliciting a conditional response. Well, it turns out that is not the case. Let us do that, let us examine that a little bit through a set of experiments here. Number one is that we are going to present this CS and US, right. I am going to call that conditional stimuli and US unconditional stimuli as CS and US respectively. Now, you can envision different kind of scenarios here. Why? In an experiment where your CS and US is completely overlapping in time, right. Time is along this axis. In such a case, this kind of conditioning or training is called simultaneous conditioning. You can later come back and then say, hey look, I am going to just present, I am just going to present just the CS alone, alright. Now, how much of the CR do I actually observe in the subject, right. That serves as a measure for our behavioral training. When you do this, you can also say, instead of co-presenting the CS and US, I am going to separate them in time. Okay. I am going to present the CS first, and then after a little bit of a time I am going to present my US. Okay. And this is called as a trace, and then again I can come and ask how well is my CR in presentation of just the CS alone. Third, I can actually present the CS, and while the CS is happening, almost at the end, okay, typically in the lab we do it at the very end of the CS, you present the US. So, there is a delay in the onset of the US here, okay. That is the key here. The onset of the CS and the US are delayed, though they are ending simultaneously. This is called as co-terminated, okay. They are both terminated together, though even though there is a difference in the onset time. Again ask, what is the CR? It turns out, if they are if the contiguity is the thing that matters, then you would see that the simultaneous conditioning has the highest level of contiguity, because they are completely overlapping with each other, while the trace conditioning is, on the other hand, has the in this scenario, among these three, has the maximum amount of discontinuity, so to speak, and the delay having somewhere in between. But it turns out, when you do this in an experiment and ask how the CRs are, simultaneous conditioning is the least learned, exhibits the least learned CR response, meaning almost nothing, next to nothing, while the delay conditioning exhibits the maximum, followed by the trace conditioning, right. It is very counterintuitive, where we have seen, if contiguity were to be the case, where there is a delay, where there is no contiguous manner, even that, the trace conditioning, right, even there you see learning, while where there is a maximum contiguity, right, maximum overlap, you do not see learning. One explanation is to say that, hey look, contiguity is not, contiguity is not the determining factor here, and that is my goal here. I am going to drive across that point, saying that it is not the contiguity, but it is something else. But there are possible explanations in line with contiguity too, meaning it is not completely ruling out the possibility it is not contiguous, but you can say that, hey look, when you present these two things together, it has to do with the performance. I mean, when you are actually asking the animal to respond by playing the CS, the association might have developed, however, the animal may not have exhibited the response simply because there is no use. The animal understands that there is no use for exhibiting that response, as a result it does not have any response. The reason why I do not emphasize on that line of thought and then go along that relates back to the idea what exactly is learned in Pavlovian conditioning. I remember I told you it is not the cognitive thinking of the dog to say that, hey look, there is a bell, and the bell is going to predict the food, as a result I need to salivate. Instead it is very much a reflexive behavior that is getting driven, where the dog tends to think the bell is the food. So, here performance based explanation would assume that the dog is cognitively thinking about the usefulness of exhibiting a response. So, we will later on go ahead and see that that is really not the case. In such a case, then why we do not see conditioning then in simultaneous during the simultaneous conditioning is the lack of something else. What is that? And probably that is the governing factor that determines whether the association is being made or not. To understand what could be the other governing factor, let us examine another little experiment that was done by Rescorla in 1968, where he introduced the notion of contingency, that is the ability of a CS in predicting the US. Okay. Remember, it is not the dog's ability to understand the CS is going to predict US, but is just simple probabilistic estimate of a CS and CS being there when the US is being present. Okay. The dog does not need to understand it in a cognitive fashion, but I mean, or any animal for that matter does not need to understand that in a cognitive fashion, but it just there is an overall estimate that you can actually mathematically write down for the predictability of the CS and US. We will get to that in a minute, but let us look at these two experiments. And experiment number 1, where I call it as contingent pairing, there are 2 USs that are being present along with the CS, okay, and there is one CS where there is no USs being present at all. In a random pairing, we will exactly repeat this. In addition to that, we will present few more unconditional stimuli. If at all anything, you would see there is more number of USs being present here. Okay. You would expect the conditioning to be as good as contingent pairing or better, because all that you are doing is that you are not taking away any of the things that are presented in the previous manner, right. You are presenting both of them, right. These are present equally in both. All that you are doing is that in addition to them you are giving more USs. In this situation, if you ask how well the animal has learned, that is how well the animal has learned to exhibit a conditional response when the CS is being played later on with or in the absence of US, you will see you have a maximum amount of learning here, while it is not even it is not equal or it is not higher, but in fact no learning, no conditioning at all in this random pairing. How can that happen? If it were to be only contingent, I mean contiguity, right, you are presenting equal amount of times. I mean you can say that okay, there is performance deficit blah 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 blue blue, but the point here is you so that the simultaneous conditioning was not working, maybe that is not a correct argument. However, here it is a very clear case where it is beyond contiguity, right, because you have whatever this is presented here and here, they are contiguous if as they are as contiguous as the contingent pairing, right. The random pairing is as contiguous as the contingent pairing. The only difference, in fact the CS with no US is also present here, the only difference is the presence of some of the USs when there is no US, when there is no CS. That is detrimental to the learning or developing an association between this CS and the US. So, now what is going on here? One possibility, one of the ideas that was put forth by Rescorla then was it is not the contiguity, but it is something to do with contingency. The notion of contingency is determined by, we will go to the board here. He said it is not just the fact that they are presented together, but it is actually the predictability, and then he defined the predictability in terms of two probabilities. The probability that a given US, given that CS has occurred, if this is high, then associativity is high, but that is not just sufficient, because if you go back and look at our previous experiment, both of them had equal amount of this probability of the US happening given that the CS has happened, because wherever the CS has happened, equal number of times the US has happened there. But it is also important to understand probability of US occurring in the absence of CS. Okay. If this is high, the associativity or the strength of association will be low, right. That makes sense, right, because you want to take, I mean evolutionarily speaking, right, our learning is highly dictated by the evolution. That is how we tend to think about how the brain works and how learning works. So, evolutionarily speaking, you are developing a response and you want to develop a response for a condition in which you know there is some predictability. That is, this, if the CS were to predict the US, then yes, you need to develop the condition. So, you need to develop the response. So, that is very simple and straightforward. However, the usefulness of the CS is not defined by how often the US happens when the CS is present, but also determined by when the CS is not present, can the US happen at all. Because if it were to happen all throughout, irrespective of whether the CS is happening or not, you will see this being high, anyway it is going to happen. The point here is it does not happen when the CS does not happen, does not occur, but it happens only and only if the CS is present, then you have the highest associativity. A function of these two probabilities, he notionally called it as contingency. Okay. It is not a I mean it is not a function that is written in terms of probability. Rescorla did not do that, but the notion was that you can talk about the predictability in terms of these two probabilities. From there, what do we gain? So, right from here we can start to think about contingencies of different kind. A contingency which is, I kind of said, higher, what I meant is where the probability of US occurring is high when there is a CS and almost nil probability of the US occurring when there is no CS. Let us call that as positive contingencies. You can also think of zero contingencies or random contingencies, where the probability of US occurring and CS occurring is not related at all. Okay. So, going to talk about positive contingencies, zero contingency, and Rescorla also recognized if these two are possible and these two probabilities are determining the contingency, then there is a third alternative that is possible, which is negative contingency. Okay. As I said, positive contingency meaning the first probability is very high, the second is less. Zero contingency being both of them being equal, and the negative contingency you can almost think intuitively the second probability is very high compared to the first one. What we predict is that there needs to be a very high association. 0 sets the baseline, while the negative contingency should predict the reverse, meaning you should develop an opposite response. Okay. We will see how we can what we mean by that opposite response and all that in a minute, but that is the idea. He can postulate just by based on this hypothesis that there are 3 different kinds of contingency that the animal can actually evaluate and decide develop its response: positive, 0 and negative, alright. So, he went ahead and tested these experiments. The experiment here is about using task called Sigmund's avoidance task. Okay. So, the task is carried out in a behavioral setup where the floor of the behavior that you see here is a stainless steel grid, okay, through which you can pass mild electric currents, and then it has 2 boxes, okay, and the barrier separating these 2 boxes has a certain height, and if you place an animal here, for the animal to go into the other box, it has to jump over this barrier to go between these 2 boxes. These are also called as shuttle boxes. They can move from one to the other, but the idea is that for it to move from one box to the other, it has to perform this behavior of jumping across the jumping over the barrier. Now, he took these boxes, and then the task he designed was to say, hey, look, I am going to present a mild electric shock. Nobody likes a electric shock, right? We all get taste of this electric shock as we grew up. We do not like it. It is not bad, but we do not like it, and animals are not any different. They do not like it too. So, they would like to avoid that experience. So, the way out for the animal to avoid that experience is that in response to that shock, if the animal jumps to the next box, for that matter, if the animal start to jump to the next box for the next 30 seconds, it is guaranteed that the animal is not going to get any electric shock. So, he would do with a preconditioning experiment in a preconditioning experiment, where on an average about in 10 seconds there will be an electric shock, mild, very mild electric shock that is given to the foot shock that is given to the animals. So, the animals understands this. So, they keep jumping from one box to the other, so that for the next 30 seconds they do not get the shock, and as a result they have this stereotypic jumping behavior from one box to the other. Now, having developed this behavior into this animal, you can use that to study the association. How we do that? He would play a tone. Now, play a tone, and then within about 10 seconds of the tone, if there is an electric shock would come. So, now he would present this 24 times, so that the animal learns to associate, okay, whenever there is a tone, learn to associate the tone with the experience of the shock. As a result, they will start to jump to the other box. So, now that is the behavior that we are actually training the animal for. So, that would form the positive contingency group, because you are with some certainty providing the electric shock upon presenting the tone. So, your tone is being presented on an average about 10 seconds, but then it is distributed about the 10-second mean. You would give the electric shock, he would give the electric shock, then you measure. The idea is that later on I am going to just play the tone and then see how well the association is developed. And of course, the random group is very simple. What you will see is that you will present electric shock whether irrespective of whether the tone is being present or not present. I mean, they are complete, I mean both of them, the onset of the tone and the electric shock is completely uncorrelated, right. They both of them are derived randomly. So, that is what the random group would be. And the animal anyway had developed this basal level jumping behavior. So, they will continue to have that behavior there too. But the negative contingency group, that is where the ingenious of this experiment lies, where he realized, hey, look, now what I can do for sure is that whenever there is a tone that is being played, I will ensure in that period there is no shock at all. So, the shock is given in a period where there is no tone at all. So, in the positive contingency group, in about there is a tone, and in about in 10 seconds delay, around that 10 seconds delay, at various places you are presenting the shock, and then the shock of course. So, I want to make sure we understand this clearly. This here I am talking about the onset times. So, the tone begins and then it ends. So, there is some time period for that tone. Within this time period all the shocks come. However, there is about a 10-second delay because you want to make sure it is a delayed conditioning. About the 10-second delay at different instance in time the shock can come. So, that is the positive contingency group, while the random contingency group has no relationship, as I was telling you, while in the negative contingency group this happens in the time period where there is no shock at all, I mean where there is no tone at all, that is in this period. Now, let us look at what the animals have learned. How do we do that? We put the animal bring the animal back into the shuttle box. Now, this time no electric shock, but just going to play the tone. What you see here is that on the right hand side the plot of the mean avoidance response, means the response is in terms of we are talking in terms of what fraction of the time they are I mean how many times they are actually jumping and stuff like that. Now, there is a basal level response during the pre-CS period. This is the period where they develop the stereotypic behavior of jumping across, right. That is same for all 3 groups. It is not surprising because you are the person who are separating in 3 different groups. Until this point they are all the same. So, they are exactly the same. However, the moment you start giving this CS and the training CS and the US training, you are separating them into 3 different groups. Now, you test them by just presenting the CS. The response that they exhibit for the CS in these 3 different groups are very different, right. This is the beauty of this experiment. You have a group of animals, they are exactly identical until the point of training, and the point they are only different in this point of training. Afterwards your testing again is exactly the same, they are not experiencing anything different. However, the behavior that they exhibit is very different just because the training is different. The positive contingency group exhibits higher amount of mean avoidance response because they are expecting the association of the CS to the US is very strong here. I mean it is positive, CS probability is above 0 here as indicated, right. So, you want to avoid that, while the random group do not show any change at all. I mean that is not surprising at all, right. It would have been a surprise when you are sticking to the contiguity principle, but here if you buy into the idea of contingency, no issues here because there is CS does not have any predictive value. So, it just does not change the behavior, the response continues to be the same as it used to be the pre-CS. However, during in the negative contingency group, when you test them during the test, you see they reduce this jumping behavior, they still that is the key here. The alteration because of the association is in both direction. You can actually increase if the CS has a higher predictive value for the shock US. Now, the absence of the US in turn acts as another different kind of a US here. The absence of a US allows the animal to modify its stereotypic behavior to reduce, because it is no point simply jumping there, you want to better conserve that energy and do something useful, right. So, that is a direct fallout of the idea that the associations are indeed governed by the contingencies, and you can modify these contingencies positive, negative and random. So, now with that I think we are just about exceeding the time limit of the lecture. We will continue in the next lecture how these contingencies with 2 other experiments determine one of the fundamental and the basic laws in psychology of learning and memory, and I will see you in the next lecture. Thank you.